sketching. We're gonna sketch the polynomial functions. You know what I'm saying? Alright, so I got these polynomial functions right here, and they're all written in factored form. They're not written in like, standard form or whatever. It's just written like with factors and stuff. And the reason why I'm writing it with factors is because it's easier to identify the zeros. And when you're sketching polynomial functions, you gotta know your zeros. And so the first thing you would do is you would factor as much as you can to have it written in factored form. So let me give you guys some quick graphs here really quick. All right, so our first one, we'll make blue. So our first graph for this f of x, it looks like we have two zeros. What are our two zeros, students? 5 and -5. So I'm going to put a dot right here. I'm going to put a dot right here. I'm going to say this is -5 and this is +5. How do we know that those are the zeros? Because they would make this 0. If I actually were to plug in -5 right here and -5 right here, I would get 0. What is -5 minus 5? -10. Man, you guys are fast. All right, and then what is -5 plus 5? 0. And what's anything times 0?
0.
See, that's why it's called a 0. And if I did the same thing with +5, that would make the other one 0, and I would still end up with a 0 when we're done. And so, how do we know how to graph this? Well, first we have to know our end behavior. Do you guys know what the degree of this one would be? What would the degree be? If I actually multiplied this thing out, it would be 2, because there's two x's, and if I multiplied it all out, we would get a degree of 2. So I'm going to do this one because it's not that bad. This is what you would get when you multiply it out. Oops. Okay, and you have a degree of 2. Oh, okay, so if you have an even degree and the leading coefficient is positive, that means you're going to have two end behaviors here, both going up. All right, now I know that I'm going to go through each of these x-intercepts for two reasons. One, each of these zeros has a multiplicity of 1. And whenever you have an odd multiplicity, let's get rid of all this other stuff right here. Whenever you have an odd multiplicity, you know that you're going to go through the x-intercept. And right now you're kind of like, what's he talking about going through? I'm going to show you guys in a second here, because this next one has something different that happens. Okay, so let's do purple for our next one. What are our zeros for the next one? Looks like a 2, and so we got a 2 right here, and a -3. So I'll put a -3 right there and a 2. Okay, what would the degree be when I finish multiplying this one out? You got to think about this for a second, because if you were to multiply this out, you would have x minus 2 times x minus 2, and then you would have to multiply it by x plus 3. What would your degree be?
3.
It would be a 3. So the degree would be 3. If you have a degree of 3, that means you have opposite endpoints. And so we're going to have to go down then up, or up then down. And we got to know where our endpoints are, because that's how we sketch. And so the leading coefficient is positive. So what does that mean? Are we going to go down then up, or are we going to go up then down for our end behavior?
Down then up.
That's right. We would go down then up. So I'm going to put these two corners right here so that I know where to start and where to end. I'm going to start down here in the lower left-hand corner, and stuff has to happen here. Let's see. When I get to the -3, I'm going to go through it. And the reason why I'm going to go through it is because it has a multiplicity of 1. Just like before. Both of these had a multiplicity of 1, so we went through the x-intercepts. So I'm going to go through these ones also. So I'm going to go through that one. Okay, I'm going to go up some arbitrary distance, because I'm not going to find the y-intercept right now. I just want to do a rough sketch. And I'm going to come back down to the 2. Now, that's kind of a problem if I was supposed to go through it. Why is that a problem? Because I'm supposed to end up here. I'm not supposed to end down here. If I go through it, I'm going to have to wrap around and go through again, but that would mean there's another x-intercept, and there's not another x-intercept. So it kind of makes sense of what I'm about to do. What is the multiplicity of x minus 2? Well, there's 2 of them. There's 2 factors that give you +2. So our multiplicity is 2. Now, if our multiplicity is even, that means we're going to bounce. So we're going to get down to the 2. What? Oh, that's a bad one. Get down to the 2, and then we're going to go boing, and then we're going to end up that way. So that is what my graph looks like. So let's do our last one. So our next one, oops, that's a really funky. What are my two x-intercepts? What are my two zeros? We get positive 5. 1, 2, 3, 4, 5. There it is. There's my positive 5 and negative 6. You say? Yeah. 1, 2, 3, 4, 5, 6. Okay, so that's negative 6. I got an x-intercept there and an x-intercept there. What is going to be my final degree when I multiply all this out? Yeah, it's going to be 5. There is a cute little shortcut that you can do. You just have to add the exponents right here. Yeah, I know. Did you guys figure that out up here too? 1 plus 1 is 2, and 2 plus 1 is 3. Okay, so I have a degree of 5, which means kind of like the degree of 3, we're going to go down then up, or we're going to go up then down. Do you guys know which one we're going to do? Are we going to be down up or up down? Down up. Okay, and the question is your leading coefficient positive or is your leading coefficient negative? Our leading coefficient for this would be positive, so this is the winner. Okay, so we gotta put down and up our end behaviors. We're gonna put one right there, we're gonna put one right there, and we have, actually I'm gonna put it way out here. So we're gonna start down here and we're gonna come at the first x-intercept from the bottom. What are we gonna do when we hit this x-intercept? The multiplicity is 2. It is an even multiplicity. Bounce. Yeah, we're gonna bounce because it's even. You see, just like we bounced on this 2 right here because it had a multiplicity of 2 that was even. So I'm gonna come at that. Actually, I don't want you right there anymore. You're in my way. We're gonna put you over here. Okay, we're gonna come out this and we're gonna bounce off of it, and then we're gonna come down some arbitrary distance. It doesn't matter. If you guys want to know exactly how far you go down, you'd have to find your y-intercept, which I don't feel like doing right now. So I bounce off of that. Now I'm coming back at the 5. All right. So when I get to that 5. What am I going to do? We have a multiplicity of 3, and it's odd, so that means we're going to go through it. Now, because it's 3, it's going to look slightly different than when it was 1. Because when it was 1, it just goes straight through it. But when it's 3, it does a little jig. You guys see that? Now, the bigger the odd multiplicity, the bigger the jig. Like, let's pretend this was an odd multiplicity of 9. Then it would look something more like this. Does that make sense?
What about 37?
Okay. 37, it would be even bigger. But we're just going to leave it at that. That is a really quick synopsis on how you guys sketch a polynomial function.